Hello, this is Ryan Scott with Team 5, along with Jordan Webb and Justin Williams, and this is our presentation for our Band in the Box. For our assignment, we had the task of designing 3 instruments to play 4 parts of Ode to Joy. The combined instruments had to fit in a box that was 2 foot by 2 foot by 2 foot, and we were constrained to a maximum budget of $15 per instrument. We also had to comply to pipe and string length constraints as well. Other requirements was that our designs had to be pleasant. They had to look good. The function of the instruments was also very important for us as a team, along with the tone, the way the instruments sound, cost, and of course the appearance was also our team goal to comply with that. So ultimately we wanted to produce instruments that were of a good design, they had a good sound to them, and that were simple to operate. So I had designed the xylophone, Jordan designed the pan flute, and Justin the box guitar. And we will discuss each one of these instruments as this presentation progresses. Hello, my name is Ryan Scott, part of Team 5, and here's my presentation of the xylophone that I designed. So the design is very basic. We have a bass right here. We have the glass keys that will generate the tones. And then underneath we have sound collection tubes. We also have, and it's maybe hard to see, rubber isolation feet that isolate the keys from the bass. So here's a brief demonstration of how the xylophone works. So here is the tone of G2. Here is A2. Here is D3. Here is G3. And here is A3. So the design is very simple. It changed over the course of time. We didn't use rubber bands to isolate the keys. We resourced some rubber standoff feet from Home Depot. Also, the bass design changed slightly due to the resourcing of recycled wood. So that changed the size. We were constrained, but it was for the positive because it made the xylophone smaller.
Hi, my name is Jordan Webb. I'm a member of Team 5 for this semester's Band in a Box project. The instrument that I chose is the pan flute, and real quick I'll give a demonstration of how it's used. So you just blow into the top of it and then you get some pretty decent sounding notes out of it. So we chose the pan flute for our hybrid instrument simply because it's easy to use and some important features we found of it. It's durable, it has a good sound quality, and it ended up being pretty cheap. So some quick selling points for the pan flute. One, the appearance. It's a pretty neat looking design. It's not boring. The tone is very good on the device. It was very easy to construct. All you had to do was just get some pipes and duct tape them all together, and it stays together pretty well. And it's also just simple and minimal materials. It's just some PVC pipe that was very easy to cut and some duct tape that ran for like $1 a roll at the dollar store. So a quick overview of the physics on the design. With the tube instrument, the shorter your tube is, the higher the frequency. So we have the lowest frequency down here on the biggest tube, and then our highest one, of course, with the shortest one. And how we calculated the lengths that we needed for each tube was a pretty simple equation that we just plugged into MATLAB. So basically you can see in the PowerPoint here, basically you just have length equals airspeed divided by 2 times the frequency. And then you subtract 0.61 times the radius 2 times. So really, to get the lengths that we need for the tubes, all we had to do was just plug in different values for that frequency variable. Then it was pretty easy to get the lengths that we needed. So overall, throughout construction, the design changed quite a few times. Originally, we planned on constructing this device out of just pipe, string, and glue. Whenever we started constructing it, we realized that that really would not be an efficient way to go about it. We would need tons of string, tons of glue, and then even then it'll probably just be falling apart. We also considered wooden tubes at first, but then they were hard to locate. They were probably going to be a little bit more expensive, so then we just ended up going with PVC. Originally, we had the radius as a little bit smaller, but we realized then that for the lengths that we would need with smaller radiuses, it would be too big for the specified box that it had to fit in. And finally, cost decreased quite a bit through prototyping. The PVC pipe ran $7.50. Duct tape was 25 cents for the amount that we used, and the total bringing that up to $7.75.
My name is Justin Williams of Team 5, and I'd like to take a couple of moments to talk about a box guitar that I have engineered. That demonstration should give you an idea of just how functional the instrument is and a taste of the superior sound quality that it generates. The instrument is also tunable. It's versatile. You can change out the strings to produce higher pitch or leave the thicker strings as I have it for lower notes. It has an integrated beverage holder and an integrated bottle opener, making it a Swiss Army knife of musical instruments. It also has a rustic appearance with genuine rust and patina on some of the hardware. I really like how it turned out. I'm excited, and hopefully you're impressed by it also. This has been a fun project to work on as a group. We've enjoyed collaborating, and we are very pleased with our final results. On behalf of Team 5, I'd like to say thank you for viewing our presentation, and we look forward to hearing any sort of feedback anyone has for us. Thank you.